Hi Bahi, this is Mr. Caslin. I wanted to go over this one problem that we're looking at where we're trying to maximize the size of a rectangle that we're going to fit inside of this parabola. Now, the problem says a rectangle has 1/4 quadrant 1 on this graph. So, for example, one of the corners would be here, the other's at the origin, the other's on the y-axis, the other is on the x-axis. Excuse me, I have trouble writing with this pen still. Alright, so we have this rectangle, right? We don't care about this side of our parabola. Remember, they gave us 9 minus x squared. You could switch those and think of that as negative x squared plus 9. So the y-intercept's at 9. It's a negative x squared. And if you solve this, you would get zeros at 3 and negative 3. And we don't care about the negative side because we're talking about the lengths of a triangle. Okay, so our rectangle is going to fit inside this polynomial. All right, so what's it asking for? First thing it asks for, express the area in terms of x. All right, so we know this length is x, so area is going to be equal to x times, well, we know y is our function, right? 9 minus x squared. If you multiply that out, you get 9x minus x to the third. So that's our function for our area in terms of x. What's it ask for next? Domain. All right, domain is just what are the allowable values? Well, the domain is going to be from 0 to 3. Now, can it include 3? Well, no, then y would be 0 and you wouldn't have a rectangle. So we're going to make that a soft bracket. On C, they're asking you to graph it. So you want to give a graph of what it looks like. And D, they're saying is what's the largest area? Remember, this is now our area function. Okay, now what I did was I used our graphing calculator to get an idea of what's this area equation look like. So let's turn this on. So I graphed the 9x minus x to the third. I graphed it. Now this is telling us for this function what's the maximum value. Well, it looks like the maximum value is going to be up here. It's hard to tell what that is. Now I'm sure in the past we've done these calc commands. We want to do a calc. We want to find the maximum value of x between where? Let's look between 0 and 3 because that's our domain. Between 0 and 3. When you say guess, just to enter. And it's telling us this maximum x is at 1.7. So they're saying the maximum x for this function that would give us the maximum area is 1.73, and I've done enough math to realize that that is the square root of, turns out to be the square root of 3. Now there may be a mathematical solution also that your teacher will give you, but that's the fastest way to get it. So remember, that's the x value, so you'd plug that into here to get what the maximum area would be. Okay, I hope that helps. What nice thing about a video is if you didn't catch all that the first time, you can replay it and look for the parts you didn't understand the first time. Now, the second problem I'm not going to go over at great length. What does it say? It says you've got y is equal to x squared minus 25. It's saying if a point on that graph, express the distance. So express the distance from point P, which is 0, 1. Excuse me, 1, 0 is one of the points. And it's saying express the distance from any point on the parabola to this point. Okay, first thing we have to do is express the distance as a function of x. So first thing we're going to do is, for everything to be a function of x, we're going to say that the input is x. If the input is x, what's the output? The output's y. Well, y is the function. Okay, so when it says express as a function of x, we need to be everything in terms of x. All right, I'm going to let you take it from here. To express the distance, you've got this distance formula. And you're basically going to use this piece and this piece, and you're going to do your x2 minus x1 squared plus y2 minus y1 squared. That's going to be your formula. And it says, what's the distance of x is equal to 2? So take your distance formula and plug x equal to 2 in there and see what you get. All right, sorry this was delayed. I hope this helps. We'll see you next week.